Hello, my name is Anthony, and today I'll be providing you with a short tutorial on how to use a new tool to WhiteboxTools called the GeneralizeClassifiedRaster tool. This tool is located within the LiDAR and remote sensing toolset extension from Whitebox Geospatial and requires a software license to use. This tool can be used to generalize a raster containing class or object features. It is extremely common in many fields and applications that rasters are derived from some sort of classification procedure. For example, landform classification and certain types of soils mapping. Rasters that are created in this way often contain many small features that make their interpretation very challenging. Therefore, it is common for practitioners to remove the smaller features. Many different approaches have been used for this task in the past, such as using a filter-based approach like a majority filter. Although this is an effective technique, it does have a disadvantage of modifying all of the boundaries in the class raster. This tool offers an alternative method for simplifying class rasters. The process begins by identifying each continuous group of cells in the input image through a clumping operation, and then defines a subset of features that are smaller than the user-specified minimum feature size. This set of features is then dealt with in three possible methods. First, the longest method, next, the largest method, and third, the nearest method. I'll go into the actual semantics of these three methods more when I talk about the tool, but today right now let's just talk about the test data set I will be using. So this is a classified raster image that has been put together through a KNN method. You can see that there are 8 classes, and this will be the test data set that we use to test the generalized classified raster tool. So let's head over to Whitebox Runner and actually load the tool. So in Whitebox Runner, you could find the tool in 2 locations. You can either search for it by typing the name or find it within its associated toolbox. The Generalized Classified Raster tool is located within the Image Processing Tools in the Classification toolbox, and the tool is in alphabetical order. So the first input is the input raster image. So let's go ahead and put that KNN image that we saw. Oops, sorry. Next, we're going to go ahead and name the output raster. Let's just call it out test.tiff. Next, we're going to set the minimum feature size to an arbitrary value of, let's say, 10. You could go ahead and alter this parameter, and altering this parameter will have impacts on the output raster, but I'm just going to pick a value of 10 for this tutorial. Next is the method. The first method, which is the default method, is the longest method. This is where a small feature may be reassigned the class value of the neighboring feature with the longest shared border. The sum of the neighboring feature size and the small feature size must be larger than the specified size threshold, and then the tool will iterate through the process of reassigning feature values to the neighboring values until each small feature has been resolved. The next method is the largest method. The largest method operates in a similar way to the longest method, except that the objects are reassigned the value of the largest neighbor. Again, this process of reassigning small feature values iterates until every small feature has been reassigned to a large neighboring feature. The third and final method is the nearest method. This method takes a different approach to resolving the reassignment of small features using a nearest generalization approach. Each grid cell contained within a small feature is reassigned the value of the nearest large neighboring feature. When there are 2 or more neighboring features that are equally distant to a small feature cell, the cell will be reassigned to the largest neighbor. For this tutorial, we're just going to use the default method, which is the longest method, but you can experiment further, and there'll be more information about each method within the WhiteboxTools manual. So let's go ahead and run the tool now. The tool performs as first a clumping operation, and then it writes the output file. It executed in about 1.8 seconds, which was fairly quick. We are using a smaller test data set, so speeds may vary, but that was pretty quick. So let's go ahead and actually view the output raster. And there we go. And one little trick I learned is you could copy the symbology of one layer to another. So let's go ahead and copy the symbology of this layer, copy style, and now let's paste the style. Easier when you're comparing similar images. So let's go ahead and zoom in on a feature area. Let's just pick this area. So you can see, for example, in the KNN classified image, which has not been, which generalized classified raster tool has not been used on, there are a lot of these small features that are really unwanted. When you go ahead and use a generalized classified raster tool with a minimum feature size of 10, a lot of these small features are removed. But let's say for whatever reason, using 10 was undesirable for your methods. So let's go ahead and bump the minimum feature size to 30. Let's just save it as something different so we don't overwrite the file. And we'll go ahead and run it again. And let's load the new layer. And once again, we will copy the symbology, paste style. So once again, here is the minimum feature size of 10, and then this is the minimum feature size of 30. So you can see a lot more of those smaller features have been classified when you bump up the minimum feature size. So this is the end of this tutorial. If you have any comments or questions, please comment down below. And thank you very much for watching this video.